All right. What we're going over today is just the concept of simple interest and compound interest. And we have a bunch of words here, and I'll just go over each one briefly. The amount of money you first put into the bank to invest, or the amount of money that you originally borrow from the bank, is called the principal. All right, so principal in the math sense is just the original amount, just like the percentage problems we've been doing. The rate is going to be the interest rate that the bank gives you. If you're investing money, then they're going to give you that percentage, and if you're borrowing money, you have to pay them back at that percentage. And when we're working these problems out, we want to do that as a decimal. 4% equals 0.04, 6.25% equal 0.0625, etc. When we're looking at the concept of time, so if we're investing the money, the longer we leave it in the bank, the more interest we make. Makes sense. So when we're dealing with time, we want to express it in years, because most interest rates are what's called per annum, which means per year. So 4 months, we're going to express it as a third of a year. If it's 8 months, it's 2/3 of a year. 6 months is half a year, etc. And I kept that a fraction and that a decimal because these fractions, we don't want any rounding. We don't want to call 8 months 0.6 recurring of a year. Okay? Finally, interest, not finally, almost finally, this is how much money we make or how much we have to pay back the bank. And this one down here, I kept this separate because this doesn't have to do with simple interest, only compounded interest. In the compound interest, how many times our interest is compounded in 1 year, we're going to represent that by n. So, for example, if it's compounded every 6 months, n's not going to equal 6, but if it's compounded every 6 months, n equals 2, because that's 2 times a year. There are 2 6-month periods in a year. And if it's compounded every 3 months, that means n doesn't equal 3, but 12 divided by 3, which is 4. Okay? So keep in mind, number of times that it's compounded per year, that doesn't mean number of months, it just means how many times in one year. Okay? So let's look at some simple interest problems first. Okay, to start off with, simple interest means that we only make money off of our original amount that we put in, known as the principal. Alright, so to figure that out, we do have a fairly straightforward formula to that. How much money we make, I'll just stick with examples of making money, so I'm not going back and forth. How much money we make depends on 3 things. How much we put in, called the principal, the interest rate the bank gives us, and the time, how long we leave it in the bank. So let's look at an example. Okay, so for our example, we're going to invest $2,100, that's the principal. The bank's going to give me an interest rate of 3.25%. I'm going to convert that to a decimal before I put it into here, and I'm going to keep it in the bank for 18 months. So when I substitute these values in, I have to watch out, because remember, time has to be in years, and the interest rate has to be as a decimal. I'm going to add one more thing here, 3.25%. You usually see this after all banks, PA, and what that means is per annum. It's a Latin term that means per year. So PA, when you see that, that just means that interest is going to be paid at the end of the year, or yearly. Okay? So let's change the rate and the time to more suitable values to put into our formula. So the values that I've highlighted right now, the values you're going to plug into the formula. 2,100 is the principal. 18 months is a year and a half. So I'm going to input 1.5 in for t. And 3.25% as a decimal is 0.0325. And how I got that was just dividing it by 100. So now the interest that I make would be okay, so the interest I make on that is $102.38, and I highlighted these parts in blue to show how I get the interest rate as a decimal. I divide it by 100. And if it's in months, how I get it to years, which is just divide by 12. Alright, so we can do more examples of simple interest, but it's relatively straightforward formula. Nothing too complicated there. Now let's look at some compound interest and see what the difference is. Alright, the difference between simple and compound interest is that compound interest is when we make interest off of our principal as well as our previous interest that we've already made. And we'll look at an example of investing $5,000 at a rate of 4%, and I'm going to keep it in the bank for 3 years. And this example will be a little bit different. Let's look at this problem and see how much interest I'd make at the end of 1 year. So at the end of 1 year, my principal and rate, I did it just divided by 100 because I got the percent as a decimal, so I showed that step. So after 1 year, I'd make $200 for my interest. Principal times rate times time. Now with compounding, this 200 is going to go back into your account. So the original amount was 5,000, and now you're going to have 200 more. So at the end of year 2, no, at the end of year 1, your new amount's going to be 5,200 in the bank. After the second year, you're going to start with 5,200 instead of 5,000, and then your interest at the second year is going to be $208. At the end of the third year, this keeps adding on to the amount in your bank. At the end of the third year, I have 5,408 times the interest rate divided by 100 to make it a decimal, times another year. So each year I make more interest. And my total interest after 3 years, there's year 1, year 2, year 3, is $624.32. Now I already had the original 5,000 in there. So that means after 3 years, before any taxes are taken out, I'd have $5,624 in the bank with these interest rates in this time. Now, of course, all of this, in New Zealand, at least, in most countries, is called taxable income. Interest is income. You're making that money. Therefore, it's going to get taxed by the government. We're leaving that out for now. Okay? Now let's look at a way. So, suppose I said, what if I left that in there for 17 years? I don't want to do this step 17 times in a row, so I want to look at something different. Alright, so for compound interest isn't just about making money in a bank. And so I just wrote down some other applications of compound interest. Population growth. If a town starts with a certain population and is growing at 3% a year, we can figure out what the population will be in a certain amount of time. This formula and this can also be used in appreciation values. So anything where its value increases over time, the opposite of depreciation. And over here I just put an example for like savings accounts, difference between U.S. and New Zealand. U.S., you're not going to get a very high interest rate on a savings account. In fact, you might get somewhere around 0, whereas New Zealand we get about 3.25% interest for a savings account, depending on how much money you have in there. So I just want to talk about the formula for compound interest real quick. The new amount A, what that part is right there is that's like this I did here, the overall amount at the end of the interest that has been added up. P is our principal, R is our rate as a decimal, N is how many times it's compounded a year. I've gone over that. And the exponent up here is the number of times it's compounded a year times how many years you leave it in the bank. Now this formula, why it looks all weird and complicated, is what I'm doing here are consecutive percent increases. It's a percent increase, and we know a percent increase is 1 plus the percent as a decimal. Well, if I do that consecutively, 2 times or 3 times or 4 times, then I'm going to raise that to an exponent, because exponents express repeated multiplication. Okay? So keep that in mind. So here's a problem where I highlighted the bits of information that you need. If I said Jack invests $1,200 at 8% per annum, compounded yearly, find his new amount after 10 years. And I just highlighted all the parts that we need to substitute into the formula. His principal is $1,200, 8% is 0.08, 10 years means t equals 10, and compounded yearly means n equals 1. So when I plug that into my compound interest formula, I get a new amount of $2,590. Okay? Now I did that kind of quickly, but remember the interest is already added into that. Okay, one more example here, and I highlighted the important parts that we need. We're going to invest $2,500 at a rate of 6%, which means that's 0.06 as a decimal, compounded every 3 months. That means 4 times a year. And we're going to keep it in the bank for 5 years. What's my new amount? After I substitute all these values into my formula, this is what I get. And I simplified down to this step just to show that if it's compounded every 3 months for 5 years, that means it's going to be compounded 20 times. So after 5 years, my new amount would be $3,300.14. Okay? Next video we're going to work on, instead of finding the new amount, we're going to see how we can find the original amount, the principal. Okay? That's it. See ya.